Okay, we are here to do 5.1. And 5.1 has to do with exponents. Okay, notice we skipped chapter 4. We do that in 115. So now we're going to go to chapter 5, and this is today is, why is it not working? Hang on, my pen is not being a pen. Okay, 5.1, which deals with exponents, okay? And we have rules, all right? The rules for exponents, we're going to start with if you multiply two things that are the same, two bases that are the same, you can, add exponents. For instance, if I had, for an example, if I had 3 to the 4th times 3 to the 7th, the bases are the same, so I can add, oops, that's supposed to be 7, I can add the exponents and make it 3 to the 11th. If I had y to the 3rd times y to the 8th times y to the 2nd, the bases are the same, so I can add exponents. So I get y to the 13th. Okay, now what if I had 5y squared times negative 3y to the 4th? Now, take the numbers and multiply them. That's 5 times negative 3. And then I have y squared and y to the 4th. Now, we know that 5 times negative 3 is negative 15, and then we can add the exponents because bases are the same, so you add the exponents. Okay, look at another one. What if I had 7pq times 2p to the 5th, q to the 2nd? Okay, you have your numbers that have to be multiplied, but then you have pq times p to the 5th, q to the 2nd. All right, 7 times 2 is 14. Now take your p's, same base, add exponents. If there's nothing there, that means there's just a 1. So what is 1 plus 5? 6. And then the q's, there's nothing there, so it's a 1 plus 2 is 3. When multiplying, same basis, add exponents. Okay? If I had x squared times y to the 4th, this does not apply because the bases are not the same. All right, let's look at the next rule. The next rule says any base to the 0 power is equal to 1, which means 6 to the 0 is 1. 325 to the 0 is 1. X to the 0 is 1. AB, the whole thing to the 0 power, is 1. Okay? Anything to the 0 power is 1. Now, this next one is where we can get a little tricky. Any base to a negative exponent becomes 1 over the base to the positive exponent. Likewise, anything that is in the denominator as a negative exponent comes up to the top as a positive exponent. So basically, negative exponents need to move either up or down. If they're in the numerator, they go to the denominator. If they're in the denominator, they go in the numerator. And that's to become positive exponents. We cannot deal with negative exponents. We can only deal with positive exponents. So let's look at an example. And this is where the majority of the mistakes are made because it just seems too easy and people don't like it, okay? If I have, let's remember, what I'm talking about is a to the negative n equals 1 over a to the n, and 1 over a to the negative n equals a to the positive n. Okay, using that. What if I had 2 to the negative 3? That becomes 1 over 2 to the positive 3, which of course is 1/8. If I had 6 to the negative 1, that becomes 1 over 6 to the positive 1, which is 1/6. Tricky. What if I had 1 over 2 to the negative 3? That comes up to be 2 to the positive 3, which is positive 8. What if I had 1 over x to the negative 4? That comes up to be x to the positive 4. So if it's in the top or the numerator, just think about it, this is over 1. So it's in the numerator, goes to the denominator. If it's in the denominator, it goes to the numerator. So then I'm going to try to trick you here, okay? I'm doing this to try to trick you. What is the difference? What if I had 5z to the negative 3 and 5z to the negative 3? What is the difference? Well, the difference here is this is the only thing that has the negative exponent. So I get 5 times 1 over z to the positive 3, or 5 over z to the positive 3. 5 gets multiplied, stays on top. 5's in the numerator. This went down to the denominator. This, on the other hand, though, says the whole thing is to the negative 3. So it becomes 1 over 5z to the positive 3, which is 1 over 5 cubed z cubed, which, we haven't done anything like that yet. So we'll just leave it like that. All right? Okay, now let's